the Green Council to give me the opportunity to share with all of you that about the climate change, the scientific aspects, and some of the extreme weather that associate with climate change. Although the Hong Kong Observatory is not the policy bureau or the department who looks after the energy policy or strategy in Hong Kong, but we are the department or the meteorological authority that provides scientific knowledge, expertise, and advice on climate change and weather aspects on that. So today I've tried to make use of the coming 20 to 25 minutes to share with you some basic issues about the climate change, the present status and extreme weather, the climate change status at this moment, and the target actually the UN is looking for, and also the extreme weather in this changing climate, how they connected to the consequence of climate change, and some of them are really close to Hong Kong and actually experienced by all of you in the last couple of years, and the future projection of climate that people may be interested to know that what is the going to trend of the future climate under the climate change scenarios. And last will be something on the public education and climate change and energy saving issues, and also a concluding remark to remind everybody the message taking home. I think this curve has been presented by Mr. Lam. I do not have a more fancy one with the logo of Observatory, but this curve, I acknowledge the source from NOAA, Met Authority in the United States. This curve has a very interesting name that I would like to let all of you know is this. It's called Keeling curve, K-E-E-L-I-N-G. This is a very famous curve that depicted the CO2 concentration change from year to year and the long-term trend. You see there's a ripples on the line of the wet ripples on the long-term increasing trend. It is actually the annual natural oscillations of the CO2 in the atmosphere. In the summertime, that we see that the trees and vegetation grow, so they consume the CO2. So they cause the CO2 to fall in the next 2 quarters, and then going up again in the spring, in the springtime when the vegetations did not grow and consume so much CO2 in the winter and spring. So we can see that these natural oscillations can easily detect using this kind of observation. But the more prominent feature is, as mentioned by Mr. Lam, is the accelerating increase. It's not just increasing trend, it's accelerating increasing trend. And now we are seeing a quite high CO2 concentration nowadays. So how high is it? If we're up to the April 22, maybe this one figure is quite interesting, that you don't know how long is it, but this is referring to the 800,000 years of CO2 concentration that we can estimate using all different kind of actual observations as well as proxy observations. You can see that over the many years, the CO2 are actually below 280 ppm. This is a very safe limit. But nowadays, where are we? We are now shooting to this value. So in simple terms, that the world nowadays, not just human, all kinds of species are experiencing atmosphere with the greenhouse gas concentration that has not been for 800,000 years. This is new challenges because you see the oscillation of the CO2 in the past can be quite sharp, up and down, but this one is probably not natural, right? So that will be a quick challenge to scientists and as well as the human being and the world species to experiencing and to adapt to this kind of rapid change in CO2 concentrations. So what's the consequence of increasing greenhouse gases? One thing that the simple physics tells us, the greenhouse effect will increase the global temperatures. And this is not just simple observations, this is also a global observations. That from these observations, that the global temperatures, average temperature that oscillate from year to year, but since the mid 1950 onward, we see this as a constant accelerating increasing trend in temperatures. In fact, the last 4 years actually is the warmest years in the world since the instrumental observations for over 150 years. So we can see that this is a very alarming feature for scientists because not just a small increase, you can see this is a 0.1, 0.2, that is much smaller than the diurnal variation of of a day, but this average over the world for many years. So you can see that this small change of about 1 degrees now, since from here to the pre-industrial age, is actually a very major change in terms of from the climatology or paleoclimatology perspective. So this may have a very high impact to the global community. And also this curve, you see that there's not just one line, there's 5 curves composed together and all depict the same trend. These 5 lines all together actually referring to 5 different databases that provide by different global centers from Japan, Europe, UK, and United States. They are all global centers using independent of data, independent analysis, they come up with the same conclusions. So this is a very robust observation of this increase in temperatures. And this is actually quite worrying indeed. So where are we now? This is the global CO2 emissions. Be careful, this is global emission of CO2, not the equivalent, right? Just the CO2 emissions. For equivalent, that you have to include other greenhouse gases. For this one, we can see that currently we are here. We are moving from here to here. Now we are here. And the red line on top is the high concentration scenario. If you are expert in this one, this is RCP 8.5. For other more optimistic scenario in the future, this is the medium high one, this is 6.0 and 4.5, and the very optimistic scenario of 2.6. This one is it's very optimistic. Okay, this is really unachievable, as I can say. This one and this one may still be able to achieve if we work together very hard. And where are we? Actually, we are now around here. Around here. Unfortunately, we are riding on the highest emission scenario situation, at least for the past few decades. And can we change the trend? That we have to talk today and see what we can do. But if we're riding on these high emission scenarios, I will show you the projections and later on and the consequence, and that will make that will require us to have a very strong effort or aggressive effort to reduce it to go to the more optimistic one. This is the medium high or medium low situation that can maintain the temperature a bit to a lower level in the future. Last year, IPCC, the Intergovernmental Panel on Climate Change, that published a very aggressive report on global warming on 1.5 degrees Celsius. 1.5 degrees Celsius is a visionary target of the IPCC or the UN that hope that we can contain the temperature rise in the future within this limit. This is not an easy target, I can tell you. But they consider that this 1.5 limit can help to restrain the effect of climate change on the whole world, not just for human beings, and maintain the sustainable development in the future of the human species. And this will require the rapid and fast-reaching and unprecedented changes in all the aspects of the society. This is a very long report. I won't spend too much time on that. Very boring indeed. But in fact, some message that tell us that just a half degrees difference from 1.5 and 2.0 degrees change in the future will have a little bit, or even not just a little bit, a quite significant change in some very impacting issues. For example, I think two of very concerning issue that therefore here we see the heat waves, the water resources, extreme rainfall, and sea level rise. This all will change to a bit to the worst side if we increase the temperature to 2 degrees, 1.5 limit. In particular, my favorite and most worrying issue is the heat wave and the sea level rise. This because these two will be the most likely or confident effect of the climate change in the future. Heat wave, you are living in Hong Kong, you know how hot in the winter, in the summer nowadays, and you cannot survive without air conditioning. Okay, of course, our directors still don't use air conditioners. I'm very mild at that. Not just directors. They are competing with our Secretary of Environment and not to use air conditioning and reduce the electric bills. So, okay, but this is a gimmick. But actually, in the future, if we increase the temperature to 2 degrees, we will see a much more frequent heat waves, not just in Hong Kong, as everywhere in the world. Heat wave is also a major killer of many people, especially the elderly with chronic diseases. Sea level rise, I think from scientists' perspective, this is the very high confidence consequence of the future climate change that will have very significant effect to the coastal areas and cities in the world. That is always, most of them are very highly populated and highly economic values. And how can we do that? This is a very complicated graph. Actually, the Paris Agreement targeting for this one, this level of emission, this unconditional NDC, this is something just national determining contribution that you are committed to reduce to that level. But actually, if we want to reduce the temperature increase in the later decades to within 2 degrees, we still have a gap of this range of emission reductions. How about 1.5? That is here. So you see the gap is still quite large if we really aggressively go to 1.5 or 2 degrees Celsius. If we don't do anything, we will go up to here. If we work something along the Paris Agreement, we may still up to 3 degrees to the end of this century. So if we want to do better than the Paris Agreement, we may need to reduce the emissions a bit further than the Paris Agreement. And even more, that if we really want to do that for 1.5 or 2 degrees Celsius, we may need to have achieved the CO2 net zero emissions around 2050 and have the emission capped around in the next 2 decades. This is a quite important target that I think quite the modern developed countries are looking for to achieve this one, including China as well. So after all these emissions and CO2 issues, what is the consequence of climate change and how it relates to the extreme weather? Very simple, there's something wrong with the slide, but it doesn't matter. Very simple consequences that enhance the greenhouse effect with more greenhouse gases in the atmosphere that will increase the temperatures globally. This is a very basic physics. Everybody knows that. No need to argue on that. But the subsequent effect is that the increased temperature will have subsequent consequent feedback effect is that the thermal expansion of the oceans and melting of the snows and ice on the ground will cause the sea level to rise. Further than that, more complicated cycle is that if you warming up the atmosphere or the Earth, that will also change the atmospheric circulations and also enhance the water cycle. That will cause the weather become more unstable and more extreme weathers will appear. So how about extreme weathers and how it relates to climate change? First of all, we have to identify what force means by extreme weather. Extreme certainly say talking about something this is not appear frequently. This is usually uncommon issues. Infrequent and unseasonal events. But of course, nowadays, the record I keep breaking every year, so we see this unseasonal event become quite seasonal. But anyway, theoretically, that unseasonal event refer to extreme on both ends of the distributions. For example, this diagram refers to the temperature distribution. If generally speaking, most of the time we stay in the center of the dumbbell shape. Sometimes we got a hot extreme and cold extreme. This is the very normal situations. So if we have a climate change, the atmosphere warming up, we were able to see several consequences. First of all, is the change of the mean. That means the whole dumbbell will move to the hot side. So you are going to see more high temperature events. The other possibility is to increase the variability. That means more variable than the normal situation. So you have a fatter dumbbell that will cause both ends to increase. But most likely consequences have both together that will cause you still have the cold end, but more on the hot ends. The hot extreme will increase. This is exactly what we saw over the last few decades in Hong Kong. For rainfall, it will be even more complicated. For extreme rainfall that we see the climate change, one basic theory is that for every degree increase in atmospheric temperature, you will expect 7% or even more room for the atmosphere to contain the water in the atmosphere. So if we warm up the atmosphere, we'll see how strong enhanced hydraulic cycles together more water holding capacity. That means the bucket on your top on the atmosphere getting bigger. So when you pull the water from the bucket, the more water will be coming down. So that will cause the change in the precipitations, the distribution from less light rain become more heavy rain. So with less light rain, you have less chance of rain, but every time it rains, it will become heavier. This is also observed in many places in the world nowadays. How about in Hong Kong? Hong Kong is a bit complicated. It affected by the background global warming, of course, but we also have the local urbanization effect that enhance the heating in the atmosphere. So, so living in Hong Kong, I'll show you the temperature trend later. The increasing temperature in Hong Kong is actually faster than the global mean. So because of the urbanization effect that add together global warming. And this is a quick summary of what we observed over the past 100 years. Because Observatory, we started our business more than 130 years ago. We have hourly data every hour in Hong Kong. So we know how it changes over the last century. And for the temperature, we can see that the increasing trend, as I can see that this, I can say that this keep increasing in the last few decades, is going to be about 0.13 degrees per decade. That is about double the rate of the global average. And also we see that the more hot days, hot nights, and less cold days when compared with century ago. And for rainfall, we have the rainfall breaking more frequently in the last few decades, and hope this can stay a bit longer. And for extreme rainfall, that we see the frequency are also increasing over the last century. And sea level, we also measure the sea level increase. And also, not just in Hong Kong, for the global sea level rise trend that go in the Asia Pacific or globally, you can see all the arrows are going up. So there are some variations from place to place due to different oceanographic issues, but in general, we can see that the sea level rise is just not a local issue, it's a global issue as well. And for temperatures now, remember the record now is going up to 36.6 in Hong Kong Observatory, and in some stations in the northern, in the new territories, can go up to about 39 degrees nowadays. And we expect that sometimes later, even we have the chance to see 40s in Hong Kong. This is a very high temperature, not just for the human comfort, maybe for the infrastructure, this is also an issue. So you see the breaking of record has not been broken for many years. Until last few decades, it keep going up like this. So this is also worrying. And I quickly go through some historical events that may have issues, but it seems to me that the PowerPoint has some issues on the figure, but doesn't matter. That for extreme hot weather, that we see that there will be mainly due to the typhoons in Hong Kong, with the temperature going up to 36.6. And also that seems to me the table is going to color cook, doesn't matter. For heavy rains, that we see that the highest heavy rain in Hong Kong is actually due to several events. The one in 2008 and one in 1926. That if the rainstorm, that can bring very heavy rain to Hong Kong and related stuff. I can see anything or black. Doesn't matter. There are also a notorious rainstorm in Hong Kong that some of us here may still remember in the 1966 and the 1972, that the rainstorm can cause landslide, flash floods, and cause a lot of casualties in Hong Kong. And on the other side of rainstorm is the drought. That's nowadays many people or younger generation does not, most of them are not aware of, because we have the Tsz-cheung water that supplies, and every day in the morning you open the tap, you have the water. But in the old days, water resources was always an issue in Hong Kong. Not in Hong Kong, and actually in the over Guangdong areas. And some people, I haven't experienced this one, I'm still young, but if you remember, we imagine that nowadays, if you have the water rationing for once every 4 days, this is horrible in Hong Kong. You cannot have the water for 4 hours nowadays. So this is a very horrible situation at that time. Until after that, the government start to have the water import from China. But nowadays, it's getting more and more expensive, of course. And typhoon, luckily this one shows quite well. For typhoon, we have many very deadly historical typhoon in Hong Kong in the past. That, for example, before the World War II, there are typhoons that can cause the death of over 10,000 people in one single incident. Remember, at that time, the population in Hong Kong is just about 300,000 or something. So the very high population of casualty at that time. And many of them are trekking on the track that is quite familiar to all of you. That is like Mangkut last year, okay? That passing to the western Hong Kong, that caused heavy casualty. And the most major cause of this heavy casualty is storm surge. And this is some statistics. And we have one magic figure that can tell how impact is. 3.5 meter. When the sea level go up to 3.5 meters in Hong Kong, we usually see there's an impact in sea level flooding, very phenomenal scenario like you see in Hang Fa Chun, there's usually that cases. So what will happen in the future? I try to summarize everything in one graph and 1 to 2 slides because it's a quite complicated stories. But generally, the take-home message that in the warming climate that we expect that we're going to be increasing CO2 in the future, we will see more variable rainfall, more frequent extreme weathers, and it's very sure that we'll be rising sea level. And for example, if we consider there are 2 cases, there's a high emission scenario, we may go up to 4 degrees or even higher, or a very optimistic scenario with 2 degrees warming. You can see the difference in the temperature changes and the rainfall changes. For higher emission scenario, you will see probably the more increase in rainfall and more frequent extreme heat wave situation or mean temperatures. And also the sea level will be changing quite significantly from 0.6 meter to maybe 0.9 meters. And in fact, IPCC is going to release a new report this year, and there may be a possibility that they will further adjust the sea level to going up again, because the acceleration of the melting of the ice sheet in the Antarctica and the Greenland has to be taken into account in the new report coming up. And I try to emphasize on the temperature further, because if we're looking more closely in the future in different emission scenarios, we will maybe going to see 3 degrees to 6 degrees increase in the temperature in Hong Kong in the high emission scenarios. And also that for high emission scenarios, the number of extreme hot days and hot nights in Hong Kong will increase significantly. And many of you are coming from the energy sector. I try to show you an interesting diagram. That's a paper going to be published this year from CUHK. You can see the energy consumption in Hong Kong using a data to how we compare with, this work is a bit small, but this is the cooling degree day. That is the energy, the temperature related to the cooling demand in the summertime especially. And you can see that different colors referring to the different decades of the relationship between the cooling degree days with the energy consumptions. If you can see that for both residential and commercial, in the old days, for example, 1960s, 1970s, and 1990s, I'm roughly from here, okay? The temperature variations are not so tied to the energy consumption. The correlation is not that high. So in the old days, the energy sector people, maybe you are too young for that, you predict the loading is just piece of cake because they don't change with the weather. Don't change much on that. But in the last 2 decades, you see there are very strong correlation with that, with very significant changes. So they are highly correlated to the temperatures and weather, in fact. So nowadays the life is much difficult because the energy or power company, they have to predict the loading. They have to take into account many factors, including the weather, because hot days, a very hot month, they will have a very high surge in the power demands. That will cause a lot of problem to them, including the peak loading, the maintenance, and also the CO2 emissions as well. So this is everything that we have to think about. And also, if we predict increase in the temperature in the future, that means this correlation will become more and more sensitive and more high correlations. And that will cause a lot of problem with the use of energy as well as the emission, because hotter weather you have used more energy, and more energy consumption will feed back to more greenhouse emissions. Okay, next will be on the tropical cyclones, my pet subject. Okay, I usually take 3 hours to talk about this topic, about tropical cyclones and climate change, but I have maybe 5 minutes, right? So I try to make it short. That many people ask what will happen in the future with tropical cyclones and the climate change. This is a very complex issue. Okay, a very complex issue. I can tell you that under the same simple physics and the future projection, we can see that under climate change, the tropical cyclone intensity and the proportional of very intense TC will increase, and the rainfall associated with tropical cyclones will also increase. And one very certain issue is the sea level rise in the future will certainly enhance the risk of the storm surge and wind waves caused by the tropical cyclones. All the hexes, all the problems will not come one by one. They come all together. One possible scenario in the future is that under climate change, that the combined heavy rain, storm surge, and wind wave and sea level rise will act together. Together with the climate change effect, you will have more sea level rise. You will going to have a more intense storm surge and wind wave, enhance the rainfall, and that all acted together, and with together wind waves, sea level rise, they will increase the impact of tropical cyclones to the coastal area, especially, including Hong Kong. In fact, this is not something in the future. It happened last year. We have the super typhoon Mangkhut that hit Hong Kong. This is the flood map that we collect all the data and report it over Hong Kong. You see flooding everywhere. So that's why you can see from all the social media that there's a very phenomenal flooding in many places and many damages. You can see many sea-wheel buildings are seeing very phenomenal and impressive wind waves that are affecting coming into their windows. This is what we are heading towards if we have more intense typhoon in the future. Last, I try to sum up with some efforts in Hong Kong. Energy policies or sometimes also increase some issues on public education and energy saving. So while we are not the department to look after all this energy policy, but we make an effort to educate the people about climate change and energy saving. For example, we have the public talk together with Hong Kong IET to schools, and we have exhibitions and collaborate with university. And also we have collaboration with power sector as well. For example, this example is from CLP. They have the meter online that predict the energy use of major users in the next 7 to 9 days, so they can ask them to reduce the energy consumption on very high loading days that can foreseeable in the next 7 days. And also some public utility events. And also we make use of every opportunity, different channels to do everything to educate people with collaboration with different departments on brochure education packages to schools. And also during open day, we have shows to show the impact of climate change. Social media, okay? They are not marvels, right? They are the league in Hong Kong of the mascot of different government departments to become the revenges, okay? Also, we have the YouTubes and everything to promote, we call it Kumia stuff, to every day, every week we have this video. Some of them are referred to climate change and aspect to educate the people about the awareness and the importance of energy saving about climate change issues. And a closing remark, I don't repeat all of them, but one thing that I would like to highlight is that to prepare for the future, what is accurate nowadays may not be good enough in the foreseeable future. So we have to plan ahead and make sure that we make best use of our effort nowadays. And also a concerned effort is very important for public to aware all the importance of climate change, their impact and extreme weather. And also a collective effort has to be required to mitigate the climate change impacts as well as reduce the greenhouse gas emission, because it's the ultimate problem. And to ensure that Hong Kong has a sustainable development in the future, as well as not just for this generation, but also the generations to come. Thank you very much.